Well, good afternoon, everyone. Thank you for attending our, is it really, it's June's BSUG. This will be the last one until this fall. We'll have another BSUGs. We'll have 2 or 3 more starting in September. I want to thank Idaho Power for sponsoring these. They've been a sponsor since the inception of these BSUGs, and they're really the largest sponsor for the Integrated Design Lab. So we really appreciate it. And you should, if you're not familiar with their programs, you should go online and make sure that you are, because they can be of great benefit to a lot of your projects. So thank you, Idaho Power. This is kind of a this is a session that I set up today because it's my friend Clay Teeter here that's going to be from Maalka, that's going to be the presenter. And Maalka a few years ago was a startup when I got to know them, and I just got to tell you, they've done some brilliant work, and they've created a platform that from which you can view data in ways that it makes it much more usable information. I'll let Clay talk more about that, but it's pretty interesting to me, and I thought for sure it'd be interesting to most of you here and out there. So with that, I'm going to turn this over to Clay and let him talk about your platform.
Thanks. Yeah, first off, I'm only here because there was free lunch and a Coke. That's really all it takes to get me into a room. But yeah, I'm Clay Teeter, and I'm a Vandal. I went to the University of Idaho, and go Vandals and all that kind of stuff. And Idaho Power, they keep my lights on at my house, so thank you for that. Without either of them, I probably wouldn't be here. So a little backstory with me. I was a Vandal. I went to University of Washington, finished my degrees over there, and got interested in kind of the, I don't know, the feel-good side of technology. I worked at Seattle Schools for a while, building out a big technology platform for them. And then I worked for another company called 3Tier, which does energy efficiency forecasting for the wind farm and the renewable energy market in general. And this really got me excited because, you know, if you look about how you model a wind farm, it's not just does this turbine spin, right? It's turbulence. There's, you know, shear factors, all these things that come on. And honestly, at the end of the day, it keeps power just to be there, right? So technology helped my company 3Tier understand, ways in which we can use technology to better help the speculators and the energy providers around that technology. And it was widely successful and eventually got purchased. But that really introduced me to this idea of using technology to, help. So we formed Maalka with my dad and a co-founder in New York City coming out of Cornell to build a platform to help people that have large sets of portfolios in the build space, like the University of Idaho or the city of Amsterdam or the city of Boise. How do you better understand what's really happening? And there's a lot of technology platforms out there that look at it from the perspective of this electrons moving through the grid, or what's this building management system doing? But there really wasn't a lot of folks out there that are looking at the bigger level. How do you roll that up into something that's interesting? And traditionally speaking, it's been a job of analysis or analysis. Yeah, that guy. But what they'll do is take spreadsheets and they'll turn that into a beautiful report, maybe using Tableau or Excel. But it's time consuming. And unfortunately, that time is what's really important. Things move forward and you have this kind of, gate where we get the data from all of the energy providers. We understand the building through the metrics. Okay, now we have to go through and build a report. That oftentimes takes years. And you can scale that back and say, okay, well, I want to have an update. And you can maybe do that in weeks or months. But given that kind of progression, it's really difficult to get that closer to real time. So that's what we try to do at Maalka, is kind of like figure out if there's a technology solution to help our customers do something like that. And I like to think proudly that we found an interesting technology that can do that. And that's called Maalka. And what exactly do we do? So Maalka is a software platform that has the ability to connect all these little pieces on the right-hand side, whether it's CSVs, Excel spreadsheets, or modeling software from like Energy Plus. Roll that together and build something that a customer wants nice, Like it looks good. You can show your boss it, right? It's an easy way to get a promotion for, $5 a building. And then what problem to kind of solve? Well, yeah, so where is that going? I mean, Maalka, really, at the end of the day, we are a technology company, but I like to think of us more of like kind of a reporting company. How do we take data that, we in this room understand and up the chain that maybe people don't quite understand, or more to the point, don't want to understand? So, the data points. I'm pretty sure we have a mix between professional and students in this realm, right? Yeah. So given through your professional work or given, your studies, there's certainly a time when you've said or been asked, here's an Excel spreadsheet, here's a CSV. Can you show me, what the year-to-year rolling average is for my set of buildings? But that's a bit of the problem, right? We have all these little pieces, like Idaho Power has these Excel spreadsheets. They're totally and completely useless, or useful. Useful. You can look at the data; it's all there, but you can't really derive information if you're comparing that to, because they're different formats. They're both equally great, but they're different. What Maalka is say, okay, we have a format from Idaho Power. We have a format from this thing. Let's database, and then let's export that to everybody and anybody that build a report. One of the partners that we've been working with is Berkeley and the Department of Energy solve this problem in a more exchange level. And this is a project called BEADS, or the Building Energy Data Exchange Specification. And but I guess you could really roll it down to their kind of stone, if you will, of data exchange. You go through and you present my formats. Power has an Excel spreadsheet. Idaho Power has a bunch of headers in that Excel spreadsheet. But what does those headers really mean? One might say energy consumption. The other one might say site name. The other one might say meter. But that's not over at PG&E. It's something else like total energy consumption or peak demand hours. So what BEADS is doing is trying to decompose what those ideas are and put them into these atomic terms that you can understand, from the software. It's easy to say, okay, what's my premise name? And we can analyze everything based upon. It's really hard to understand. These are the 15 premise name. That's moving along, and they're doing a lot of work with EPA, with the private sector to try to normalize, your CAD software with your Haystack, with your, Energy Plus. So one of the core work with LVNL, and we can consume their atomic terms. We can lift the transformations onto a third party, and that's where software is right now. Like, is there a tool to use, or is there a project that can work together? And that's sorry. I don't know. Thanks. Hello. All right, I guess we're good. That has something to do with my hands. Yeah, so I bring up BEADS specifically because I think that while it is in kind of an infancy, and there is being money from the Department of Energy to put it together, I think that everybody at some point, like in the next 10 years, will at least have used part of it either indirectly or directly, because it is being built into a lot of kind of analytic software, into modeling software, all those kind of pieces. And specifically, if you're working with Energy Plus, that's becoming a core part of it. And the reason why is obvious, right? I can import Idaho Power data. I can export something into Haystack, and everybody kind of understands the same vernacular. Okay, what's the next slide say? Not a normalization. All right, so another issue, like we looked at like what the headers are called. Another part of this is what's inside that data. We were working with a project with one of our corporate clients, and you get a bunch of data for all sorts of different things, and they're all of different types, right? So let's say we're working in diesel, right? Diesel might be volumes of whatever, It might be, an energy coefficient by weight. It might be all sorts of things that derive into, at the end of the day, kilowatt hours. The same thing with like fuel oil 1, 2, 5, Coke, name it. They're all like these different types, and they all have these different units, but they need to be kind of normalized to a sense so you can do these analytics on them. And that's another core piece of software that we're writing is, as software is coming in, let's take a look to see what the actual definition of this thing is, turn this thing into a constant unit set, and then just forget about units throughout the rest of the system. If you look at it from the perspective of it's an input and an output problem, not an input problem, not a compilation and kind of the black box, things become a lot easier, right? If we all know everything's in kilowatt hours, it's great, but everyone knows it's really difficult to go into kilowatt hours from all sorts of different things, like say a cord of wood. But we put a lot of time into trying to figure that out so we can build these real-time streaming applications around energy software. And yeah, so this picture is a bit of an example of that. So in this case, we're pulling in real-time data, and this is actually, I think, from Idaho Power. So it's coming in from really whatever you specify it is. In some cases, if you're looking at, we're working with a partner called Urginet. Urginet does real-time movement of billing data from, say, Idaho Power into a known form. So you don't have the I'm working with PG&E problem along with the Idaho Power problem. So as things are moving forward to the system, what we do is we normalize it both by units and normalize it by time. Right? Because again, chunks of time are a lot easier to work than like kind of non-normalized data. So when you take this data coming through, just we all know it's all the same kind of thing, just throw a heat map on it, right? Because we know it's apples to apples at this point, and that's what this is kind of representing. Yep. So here we go. Yeah. So as things are moving to the right, some of my sheet when I was looking at this, right, it was all at once. So it's kind of like moving forward, that was the right. So here again, like we're taking this data that's been normalized with a heat map on it, but we can start doing analytics on it with the same thing. Let's turn this into monthly data. Let's turn this into annual data. And I'll show you a demo at the end where we're doing this in real time, from either a data entry, like Excel spreadsheet perspective, or, kind of through a precision processing system. But things just kind of move to the left as long as you're looking at apples and apples. As soon as oranges get involved, things become really hard. With the one exception, which is timestamps. Timestamps will never be easy, and in particular, time zones. Yep. So there we go. So now we were able to move from the building into kind of a raw yet normalized sense, into a monthly normalized, and then into a yearly normalized form. This is cool. So we did, so Maalka, our V1 platform that Ken's been kind of part of, we looked at that as kind of a proof of concept. Can we build something up quickly that solves the needs for a client, in a good fashion? And I think for the most part we did that. I'm looking at Ken, but I think for the most part we accomplished that. But in V2, we're taking this puzzle pieces, right? These are the, we have smart meters, we have green button, we have data visualization, we have data collection and data analytics. And I'm not sure what the next one is if I push right, so I'll just kind of talk about the entire thing. We kind of put that in steroids. So there's, in the data processing realm, there's lots of different ways to process huge amounts of data. One of the big pieces of technology that's really been around and really mature is a batch processing system called Spark. What you do is you take a terabyte of data. This can be of any form, whatever you want. It moves into Spark, and then it looks at it from the map reduce functionality from Google. Big data, smaller data, smaller data, smaller data, smaller data, smaller data, and then you get one number. And that works great if you have a system in which you know all the data up front, because it takes time to pull things together into that one number. So because we have this real-time application, we're looking at this not from the perspective of we upload a CSV and we process it. What we're looking at it is when we upload this thing, and this thing being like one of those atomic terms from beads, what happens? And you can look at it from the the physical realm. Like I wave my hand this way, and this air particles moving along this, and it all reacts and all kind of understands itself, from the atomic term or from the atomic sense. So think about doing analytics from that perspective, right? If we don't necessarily need to care, from the outside of that particular element or that atom, what the other atoms are doing, we just kind of respond to stimulus. You can start looking at things from like a streaming perspective. Like if you're looking at real time, right? Not every month or every year or every week, but as soon as you push a button, the entire system comes to life. It comes to life. That's what we're trying to do here. So each one of these pieces that come in through this graphic on my screen that I can't read, if I turn it around, they all have like little components of it. Like when the smart meter runs, it might be a 5-second like pull and it goes into the system. Every time that happens, something else happens. And the software we're using is called Flink. We're using Kafka as kind of this message passing and storage protocol, so we can have these things kind of work together. But at the end of the day, when any one of these pieces move together, whether it's your IoT or API or CSV or even the web, everything changes, right? And everything changes in real time. And I think that is pretty cool. There we go, got another screen. Yeah, so arrow goes point, we collect the data in real time, we validate said data, although with this is with the new version, it goes down, so the arrow comes to data collection and data validation. And then lastly, into data analysis. So we'll go through a particular like scenario. Let's say we have a UI, and the UI has an Excel spreadsheet built into it. We've configured, a portfolio of buildings, let's say the University of Idaho, and maybe for whatever reason, they're doing a energy management plan. So they build up a big energy management plan with all of this, big contractors and big amount of money. They want it to live forever. So they take that energy management plan, move it into Maalka, and plug in each one of the pieces that they were working with the contractors. So at some point they talk to Vista, I think, up in Moscow, and they have the plugs in there, they have all this kind of stuff. But what happens if someone makes a mistake, right? The spreadsheet comes up, someone's new, someone just logged in, and they type in 10 million kilowatt hours instead of 10,000 kilowatt hours. In the more traditional sense, things move forward and everything's great, but it's wrong, right? We know it's wrong. From historical speaking, we know that that number shouldn't have been, or maybe it was right, but it probably is wrong. So the data is collected. It goes through validation. It's instantly flagged as incorrect, right? It passes through, and each one of these kind of atomic pieces moving through this stream, they're all signed. Not as complicated as, say, a blockchain, but every piece of data moving through a system is signed with a source and the progress and the history of how something was produced, right? So in this case, the log chain would be something like entered through UI, passed initial like consistency checks, but it failed validation. That's fine. And from that kind of atomic sense, who cares? I'm just going to pass it through, but I'm going to sign this thing is not right. Data analysis picks it up and says, okay, look, I have new data coming in, but we know it's wrong. Because of this path, now you can say, big red flag, hey, it's wrong. But you can see it in both cases. Like, I want to filter all bad data, or I want to see all bad data, right? So from the UI perspective or from the data analytics side, you can say, well, maybe this is right. We're just going to let it pass through. This is what the actual energy footprint looks now. But it's probably not right, so we're going to tell people about it. And if you don't want to see it, we can hide all this information. It's up to the person that's trying to tell the story what they want to see. It's not really Maalka's job. It's just us informing folks on what we think based upon their rules, which is right and wrong. And these configurations and these validations, of course, you can configure. Like in this case, 100 million kilowatt hours is too much. So raise a flag. Oh no, I was talking too long. I may have lost my internet. That slide's dead. Okay. So, okay. I just want to talk about this because it's really cool. Energy Plus. Energy Plus is a building modeling tool developed by the Department of Energy. And what it can do, at least we can do lots of things. But what we're really interested in what it can do is rapid modeling of buildings. One thing that, our partners and competitors do really well is I want to build, a model. Let's say we're working with the library at the University of Idaho. I want to understand the the characteristics of that building, at either a really granular scope or a really macro scope, Energy Plus can help do that, right? And at the bare minimum, it requires like 5 fields, like your zip code, I think, the year built so it can get like code information, and a name, a couple other things, but generally speaking, to do a very rudimentary model of a building, it doesn't take a lot, right? It's really when it was built for the code, how big it is, whether it's above ground, below ground. And if you pass this information to this model, you can get a very basic understanding, of the characteristics of a building. So what our idea is, what if we do the same thing, but do it really big? It's kind of the first step in that life cycle of the building, where it's constructed, it's been around for 10 years, and we're trying to always make it better, always make it better. But you got to start somewhere, right? And oftentimes it wasn't in 1970, oftentimes it's like 2019. What's the baseline? And the baseline can be wrong, but we're going to kind of assume that it's near. And if we can go through and use Energy Plus and use Maalka as like that data feeding mechanism, we believe, and this real-time streaming, we believe that we can say, take the entire city of Boise, get the square footage of each building, the type of the building, or just basic information the courthouse or the state or the city hall already has, and do a very basic model of the building. And the entire piece, I think, the results are pretty cool, right? Like, let's say you're Idaho Power and you're looking to put your energy efficiency measures somewhere. You're trying to give, money for upgrades in certain places. Currently speaking, it's kind of a hit or miss thing. A lot of cold calls, when last time you updated your lights, those kind of things. But if you can look at it from the energy data perspective, it's more appealing, we think, from the sustainability side, as a tool for folks to understand large sets of buildings, like let's say the entire state of California, where people should start looking at, who's using the energy, and is there something that we can do to help? And people get, well, at least last year when I was here more often, you could always get those like LED lights at Walmart, right? Now we can kind of target it and say, look, this building has a huge amount of energy. We were going to call you anyway, but let's pull up your building. Let's say, okay, well, you're using a lot of energy to build this time. We don't see like any retrofits you might have, but we'll call you and say, hey, we have some lights. Do you want them? And then kind of off to the races from that. But it's a cool integration that I think that has a pretty big upside. I think I kind of already went through this. I didn't talk about the reporting and the expansion stuff though. So I talked about earlier, if you look at the idea of like beads for one, or normalization from the perspective of units, not necessarily from data, and look at that from the client perspective, you can do a lot of really cool things and do a lot of things really quickly. And that's what we did. That's what we worked with Ken, was taking data, moving it really quickly, using development paradigms to create a UI, which, I mean, it's not easy, but once you start componentizing these things, become easier. You start getting this reporting, and that reporting is really what, at the end of the day, people want to see. Outside of people in this room, the mayor of Boise doesn't really want to see the Excel spreadsheet from Idaho Power. They want to say, okay, I have confidence that the people working for me have given me the right information to make the right choice next time I'm in front of the board. And I think one thing that's come out of Maalka, and just like generally speaking, software development in general, if you can generalize the analytics side and the output, you can start building the reporting and expansion really easily. And our partners, like the city of Pittsburgh, right? They took the same data and through a trivial amount of money, we put together a report that it was to their specifications that showed energy progress and what's called RECs, renewable energy. What C is in RECs, regional energy certificates. Credits. Yeah, credits. Yeah, renewable energy credits. Because they really wanted to understand, what the real amount of money is versus the credits they're getting to the city of Pittsburgh. So we put together a piece of software really quickly that ingested all that normalized data, did our processing, did our validation, and then up the other side, for a small amount of money, became this report that they're selling all over, over the state over there. And it's kind of a neat little win. The expansion side is, I believe in this case, looking at how do you talk out of our system? So we, as a platform, we're in the business of, kind of doing, the data platform, part of it. But the other side is, we want to enable developers like, students at the University of Idaho or Idaho Power or a contracting gig to be able to access this normalized data. We put a lot of time and effort and spend a lot of money on those little like pipelines I was talking about earlier. But wouldn't it be really great if anybody could come on and create that? Like Tableau is fantastic, right? I like Tableau. Wish I would have bought stock in them a long time ago. They're public. In any case, it doesn't matter. They're worth a lot of money right now. And what they don't do really well is modeling, right? You can do visualizations all over the place. But as soon as you want to put a model in there, it doesn't work. It's just not one of their primary use cases. But if you could use an input source from Maalka into Tableau, right, you could then start building these reports off real-time data with real analytics data and real energy data. So that's what that expansion is how do you move the data from like our kind of silo into the rest of the world in a really easy fashion. And CSVs are one way to do it. API is another way to do it. And I guess you would make the argument, the PDF report is another way to do it for people. But we don't want to silo our data. At the end of the day, it's not our data anyway, right? We're just kind of analyzing it. And this next one, yeah, oh, this is awesome. So this is an example, right? We did this one for the Better Buildings Challenge in Washington, D.C. And what this was can we go through and build a simple little report? And that's what you're seeing on the left for the city of Chicago, I think, ended up with this. But to show, progress, the mouse over here, yeah, show progress of a site from a baseline year over the course of, I think it's like 10 years for this sites. But look to see exactly how it's progressing, not necessarily even just with itself. So in this case, right, hit a goal. The challenge basically is, can I have energy reduction over some amount of time, 10 years, I think, of amount of time. And if I hit it, that's great. If I don't think there's really any penalty for not doing it. But this building right here, it's all great. And they really put a lot of energy into, building, making the buildings efficient. And they hit their goal right there. It's doing 23% better than I thought it would do, and everything's great for that building. But the aspect of portfolios as a whole, you'll see here at the right-hand side, or the bars are showing not just its building, but the other buildings within the challenge as well. All right, how is my building sticking up or competing with this other building within it? So from the portfolio managers, they can say, we should direct our energy towards this thing and this thing and this thing. These aren't necessarily real time in the sense of instantaneous. So this is all mostly done on like monthly kind of billing data that we parse, normalize, and validate. And a lot of our clients are doing stuff like this. We consume their data, we clean their data, we make the data accessible. And then they're like, okay, well, let's build a report that normally would be doing in Acrobat or something like that, and do it in Maalka. And then everybody can see it. Yeah, and this is another example that we did. This was for the state of California. What this was doing was, it's Prop 39. It's a school initiative to retrofit and make the schools in California more efficient. We put this together using our data sets. I think this all in all took 3 days, and I don't know, it came out pretty nicely. It's not open to the world. But it does show things like how much money was spent, how much savings were spent based upon the data. I think there was something like 120 gigabytes of data that we parsed with this thing, and we reduced it to what they wanted, which was honestly this page. And everything's clickable. You can click here and everything changes. You can drag these bars and everything changes. The data is supposed to be alive. Yeah, and this is talking a little bit about, the Energy Plus stuff. And that one's loading. Okay. We'll see where that goes. First off, are there any questions? My background is mostly technology. I think everything I've learned about building sciences and energy efficiency outside of renewable like power generation I've learned at this company. And I can answer some of those questions to the best of my knowledge. But if you have any technology questions about what we're doing, how things are working, or just generally if you have this case, how might I look at solving it? Be happy to open up to comments or questions, or I can show you a demo. How about you guys drive it for the next 30 minutes? Yeah.
Yeah, hi. When you approach a city, do you speak mostly with their energy efficiency person, or do you ever speak to city planners, or who do you interact with primarily at the first with the first contact?
Yeah, thank you. It's a great question. It's actually a bunch of different people. It's really hard to work with the city, right? They're busy, they're cash strapped. It's from the technology side, it's hard to get in there. So what we've been looking at is if we know somebody in the city of Los Angeles, we'll chat with them. But what is more happens, or so you talk to people like Ken, or you talk to local initiative groups. 2030 is a big partner of ours. And they already have these networks of cities that the cities have already voluntarily joined, right? So from that perspective, we're helping the city, but we're helping the city through kind of a neutral third party. And that process works really well. And the biggest reason is if you work with a group like 2030, they have like 60 cities or something like that. They're asking for basically the same thing. Right. So when we talk to 2030, it's like, okay, with the city of Pittsburgh, we like what's going on. Do you have any ideas on how we might be able to speed this up or slow this down? And you work with them, right? And they come up with the money. They understand their particular problems. That rolls back into Maalka. And at Maalka, what we do is, okay, well, that's fantastic, but we want everybody, to be able to participate in this as well. So they spend the money to, build up the reports, generally speaking, is what they want, or their data collection means. We bring it back into our software development arm. Then we bring it back into 2030, which is our partner. And then they bring that to everybody as part of that group. So Seattle, Pittsburgh, Chicago, Boston, right? They can bring that all back in. And if you look at a synergy from that, it's all these cities that all have, they're all very unique. They're all very proud. And they all want to be able to share their success stories. Right. So in Pittsburgh's case, they came up with this idea, but Boston wants it a lot. So it can kind of move through us, through 2030 into Boston, without necessarily having somebody on the ground, talking to. And then the other ones are just kind of mix and match and opportunity. The private side is it's harder and easier at the same time. So if you're working with somebody like, say, Bank of America, right? They have a very strict financial interest in, say, their carbon footprint or their portfolios, but their perspective, while similar to like energy, their mandate is saving dollars, right? So the city of Boise might be looking at carbon footprint, but Bank of America wants to shave 5% off. So everything kind of changes around that, but the same kind of thing applies. When you start working with a client, you start developing these ideas, and things kind of reduce a little bit. And when you find that reduction, you can start, banks talk as well, like Citigroup's huge. And they talk to other banks and other banks, and they have efficiency measures that they work together with. And that's another way to look at it from the private sector. But they're often speaking, you find somebody that, really knows what they're talking about, and you work with them to really boil that down and then let them roll with it. Long-winded answer.
I have a question or something for you to expand on a little bit here. I don't know if everybody caught it, but what Clay was talking about earlier, it sounds like you can take utility data, say, for a number of buildings, and in one sense, you can almost do a virtual audit. You can pinpoint through the data running through the database or through the Maalka platform. you can actually start to see trends in the data, or you can start to see things about the building itself. Yeah.
Because yeah, that's absolutely right. Let me just show you some pretty pictures. I got to figure out how to get over here. Okay. Let's see. And this is the city. This is Pierce County. So in this municipalities, what's been it's not in most cases, but so Energy Star Portfolio Manager. I'm sure everybody at some point has heard that term and worked with them. From the municipality level, there's either mandates or kind of a I don't know, want to use a piece of software like that. And then through, our experiences with Ken has been similar. I'd say 30% of about 50% of the cities have been using Portfolio Manager. And, some cities are doing really well, some cities aren't doing really well from the perspective of data collection. And a lot of the work, like that life cycle of a building, right, where, it was built in 1970, but we don't actually care about anything from the energy efficiency side until 2018. There's this race to get all this data into something, and Portfolio Manager is kind of the de facto at this point. So this is the V2 stuff of us. And to Ken's point, one of the cool things, I'll kind of show you like a little bit of it. In this case, this is the county of Pierce. This is Pierce County, Washington, yeah. So we're breaking things down about like all the cities in that county, the regions within that. We get Carver, Tacoma, and this space type. This is just staging data at this point, so some of this stuff doesn't apply. You can look at maps and where these buildings are. Unless my developers broke this today, yeah. It's like where they are in the world. You can click on it and go to a building, that kind of thing. From Seth's perspective, what he really enjoys is this page working to start with. Oh, there it goes. It's this kind of stuff. So this is the analytics that was just being talked about. The internet's really slow here. This is real time, yeah. Dun, dun, dun. Might be doing something in the back end. But when this comes up, we're basically aggregating all this stuff into buckets: energy types, water types, waste types, emissions types, weather types, and kind of other metrics. Let's try a different building. How about that? Let's refresh. Yeah, we're working with that with our corporate clients. There's a utility provider, well, I guess it's a third party that we're using called UrgentNet. And what their business model is you work with, Cal Edison, and they normalize that first step. They have a team of, 500 people, and they literally read those bills, and they enter it into a form that I was going to show you. This is all off Portfolio Manager. Sorry, it's not going to work. But this is all after Portfolio Manager, right? So back to municipalities, when Maalka gets involved, it's usually, right about the time they're getting into Portfolio Manager or right after that time. So we have integration with Portfolio Manager. You can pull data in, you can push the data out, and while Portfolio Manager is great, the UI has something to be, lived with. I wanted to show you our UI for that. I'm not sure with that. But yeah, so that perspective is two-way, but that's really is very monthly data. In the case of like UrgentNet and the other providers, it's more instantaneous, right? So one of our corporate clients, this happens to be monthly. Every month it gets pushed into our servers. We process that data. We send messages out saying, hey, look, we have this new data in here for you, and all the other kind of fun stuff that comes along. I want to try one thing in particular that I think's really cool, possibly. Maybe the internet just stopped working because it wasn't working with Dropbox either. Yeah, so the validation side is what they're really interested in. This corporate client is money based, so it's not a private space, or it's not a public space. So what they're looking at is to make sure that they're getting billed the right thing, right? So their validation rules are, for month to month averages, it doesn't increase by so much. Year to year doesn't increase more than we expect, and then flags happen over that. The end result in this case is carbon, but it's around money that they're really focusing on this first little part. Yeah, and that's back to the audits, right? So when data comes back in and you have all this stuff, you can look at the perspective of is the data right? You can look at the perspective of is this building more or less than it should? You can do those checks that you're talking about, and I can try showing you again. Maybe it'll look different. I don't know, maybe it's this internet. But yeah, that all kind of comes together. From the technology side, again, my background's over there. I think some of the cool things that are working together in analytics. I was talking about Flink and Spark. There's other kind of big data analytics packages, but I think there's a pretty cool transition, like with the, stop me if I go too deep into tech. So traditional ways of like doing like large data clusters for analytics, right, is you start up something like SGE, like a big schedule. You have a bunch of nodes sitting on AWS or a cluster back in yourself. You run these jobs, and this job would be something like I have to do a turbulence model for a wind farm. You'll push up, a huge like weather forecasting grid, like sometimes down to the feet or less, based upon whether it's from the National Weather Service or Europeans or whatever, and you'll model these things down into these turbulences. And when I was working at 3-tier doing this stuff, it was kind of a pain in the butt, right? You had to manage these big systems. Each one of the systems had to be updated, all the kind of stuff that went around that. What's really happened in the past, I'd say 4 years, really, is that idea of, we have to have a supercomputer to solve all the world's problems isn't really the case anymore. What you really have to do is have an intelligent system to take over the world and do all that kind of stuff. So there's these fantastic technology products, like one is called Docker. Docker is, the idea is I can take a bytecode exact copy of something I want to run off my laptop, and I can run it anywhere in the world. It's portable. It's kind of what VMware was trying to do, but it's much smaller, and you can run them all in parallel without having to have the entire VM like setups. So what you can do with something like Energy Plus, which Energy Plus is this big monolithic like piece of software, it has Windows UIs and all this kind of stuff, but you can compress this thing down. It is parallelizable. So you can go down the traditional sense of actually like building up a supercomputer, putting a bunch of Energy Plus models on it, and then hitting go. Or you can look at this kind of new way of doing, kind of technology in general is I want to take little components of this Energy Plus model or this application and spread that dynamically around a system. So Docker images are really good at saying, I want to write this bytecode somewhere, which is usually Linux-based or something like that. There's another piece of software which is more of a scheduler around that. It's a couple of them, but the one that we're using is called Kube. And what Kube allows you to do is dynamically build kind of like big platforms of stuff around this over a big supercomputer. So you can look at, I want to rent out, 15 high-end nodes on Azure or AWS, install an overarching system called Kube on top of that, and I can start deploying things to it, right? And have scheduling understand when things should be firing, when things shouldn't be firing. So let's say we're going to run the entire state of California, right? Which is something like 30 million buildings plus, maybe even more than that. It's a lot of buildings right there, right? I mean, that's just like schools. It's just a lot. If you look at it from the financial perspective of I want to run a model everywhere, and you have to look at the max like I was doing at 3-tier, which is I got to run everything. You're looking at millions upon millions of dollars just to turn it on, right? But if you're looking at something more from the streaming dynamic application, you can fire up, run something, and turn it off as soon as you're done, right? So this kind of this shift from kind of I guess metal to VMs to like managed Docker has given developers like myself and engineers the ability to use a surgical knife to figure out how things should run, when they should run, and the byproduct is it's cheaper, and honestly, it's way easier to manage. right? Because you're not going through and doing system updates everywhere. You're updating one image somewhere, you're pushing it all up, and then you just run it. And then the result of it's like on NFS or some data point like that. And then you can use a piece of software like Maalka to feed that stuff in. So I think that, the consulting model around, kind of audits and all that kind of stuff, I think that it's going to become a lot easier, right, as technology builds up, like whether it's from Maalka or having access to more of the DOE publicly funded applications, will speed up that process a lot. And I think it'll give you, better data at the end of it. And if it's bad data, I think you'll probably know it more than, someone in a cubicle somewhere entering one extra zero at the end of it. So that's one of the cool trends I've seen that, fortunately we're in the thick of it. The other one is signing data. Everyone knows Bitcoin and all that kind of stuff. But this is kind of like the data audit. If you have 3 parties working and they're all working, whether it's like a financial or we'll just take PII out of it, or like energy data, understanding where that data was sourced, where it was transformed, and where it was validated and where it was displayed is really interesting from the audit perspective, right? Everyone wants, it's probably a terrible example, I won't use that one. But I like to know as a developer and as an engineer where something broke. And, if you pull data across those little pieces and you're like, well, that sign's wrong, or, this chain broke, it's right there. And I know exactly what process inside that entire chain to go through and write my test and debug it. I think that'll be a big deal, I think, over time once processing becomes a bit bigger. Yeah, and then MacBooks are great for developing. Hey.
So I was wondering, from your experience with on the private side, how often do companies want to go beyond what they think is their economic proposition to a broader sustainability proposition? And is that, are we talking just about the ROI and what cutoff points, for example, how far out? Because everything's going to probably go up, super long run, but there's some things that are going to
Yeah, I think, yes, the question was, from the perspective of, right, from the private sector, is there, the value proposition, is it the same between the two? Is that what we kind of get at? Like from
it's different from the public sector, and then the public is very proud of,
Yeah, I think the big difference is the public sector is responsible to the people, and the private sector is responsible to shareholders. And the private sector, you'd be completely amazed, and I can't tell you the folks that I'm talking about, how conscious they are of that. The people that run these companies are smart people, and they look at it from the money perspective. But what's turning out is the money perspective is that environmental perspective and that efficiency perspective. And it's not necessarily just dimmer lights, but it's sourcing product, right? Let's say hypothetically it's from a war drawn out place, right? There's both a human and economic cost to bringing something in from a conflict zone. And from the private sector, they're very conscious of that, if not more so than the city of Boise. It's surprising having these conversations where you'd think this company would not be where they are and what they're talking about, but then they talk about the numbers and the forecast they have, especially with the climate and all that kind of stuff.
The reason I ask is because I think that probably, there are different colors of companies, and a lot of companies, their market, they're focused on marketing.
Mm-hmm.
Sustainability primarily, and not food so much, and
Mm-hmm.
so the market, what they might want to do anyway, because it's going to save them money, and it's The question, what is really sustainability?
Mhm.
You know, is that sustainability or is it sustainability when they're actually going beyond what they might want to do otherwise?
Yeah, I'll go back to what I said before. Like, the company will say one thing, and they'll say something that, you know, their customers want or their shareholders want. What they do is very different than that. Especially in the energy sector, right? If you're out drilling oil, right? They're smart people. They understand risk management and they understand the actual cost and not just the dollar cost. And everybody hedges. And they're looking at both the case of where oil prices go up, oil prices go down, carbon gets taxed, all that stuff. And those are the kind of, that's the sector that I'm kind of referring to. They say things, however, you know, they're smart people, and at the end of the day, they're after saving money. And the way that seems like things are moving is, whether people want to say it or not, the climate is changing, and with that change is financial risk. And with that financial risk has dollars on it. And they will go one way or another based upon what their internal team says, not necessarily what they're telling us.
David?
Oh, Kubernetes, yeah. Yeah, the other ones are like, what is it? Mesosphere is another big one. But yeah, it's Kubernetes. Online question, tech related.
Well, how are we on questions here, and how are you on the presentation? I appreciate it.
Yeah, of course.
Everybody good? Is there any other questions for Clay before we wrap it up? Want to thank you for coming. What you're doing is, I obviously think it's real important. I appreciate your coming here. Clay, on Sunday, will be going back to Europe for a year. He just got back, it seems like a month ago. Probably a little bit longer than that, but he likes it there, and being the programmer that he is, he can work from pretty much anywhere he wants in the world. So we really appreciate you taking the time today and come talk to us, Clay. Thank you. Give him a hand.